Time units are a little simpler than all the other unit conversions we've discussed, in that there's only one system. The metric, imperial, US customary systems, they all use the same basic scale of minutes, seconds, hours, days, and years. While this system doesn't follow the convenient powers of 10 metric conversion approach, most people are still just intimately familiar with the various conversion factors. There's 60 seconds in a minute, 60 minutes an hour, and 24 hours in a day. And that's just because we work with all of these on a practically daily basis. Now, the only place where things get a little tricky is with years. A year is technically defined as the time it takes the Earth to make one orbit around the sun. Now, as a practical matter, we usually just call that 365 days. But the actual number isn't quite so nice. It's really closer to 365.25 or 365 and a quarter, which means that every year that passes, the calendar gets another quarter of a year off from the actual position of the Earth. And after 4 years, this inaccuracy becomes 0.25 times 4, or a full day, which is the point where we make a correction by inserting a leap day into the calendar at the end of February, making that year 365 days. Again, as a practical matter, whenever you see a question that involves both years and days, it will usually include some kind of statement about the number of days you should assume, right? Absent any specific statement or some other information like the actual year where you could determine for yourself if it was a leap year, I would just assume the more common 365 value. Now, another value that you'll sometimes see used in older text is 360 days per year. This actually has a name. It's called the banker's rule and was often used in financial calculations prior to the advent of handheld calculators. Now, for a lot of financial applications, the difference between using 360 versus using 365 was really pretty small, and in a lot of situations, 360 was just more convenient. Now, you shouldn't ever really use this today, since modern calculators and computers have eliminated the difficulties that made this approximation useful. I just mentioned it here, however, since you may see it occasionally in some older texts and some places on the internet. All right, so let's look at a quick example here. Right? I want to know how many seconds there are in 1 hour. To do this, we're going to use just the classic unit conversion approach that we've used for all of the other conversions that we've done here. So we're going to start with 1 hour, and I need to get to seconds. Now, I don't have a conversion for hours to seconds, so I'm going to have to do this in 2 steps. First, I'm going to take this to minutes, right? And there's 60 minutes in 1 hour. And then I'm going to take it to seconds, right? There's 60 seconds, 60 seconds in 1 minute. The minutes cancel, the hours cancel. All that's left is seconds. Good, that's what I wanted. And 60 times 60, that's 3,600. So there's 3,600 seconds in 1 minute. All right, so I got one more here for us. How many seconds are there in a year? All right, well, again, this is what I talked about a couple slides back. There's no mention of how many days are in a year or what specifically we're talking about. So I'm going to assume there's 365. So we'll start with 1 year. And there's 365 days in 1 year. And there's 24 hours in 1 day. So now the years are gone and the days are gone. Now we're going to go into minutes. There's 60 minutes in 1 hour. The hours are gone. One more factor, 60 seconds in 1 minute. The minutes cancel. We've got a lot of multiplying to do. 365 times 24 times 60 times 60. That comes out to 31536 and 3 zeros. So there's about 31.5 million seconds in a year. So in the next lecture, we're going to switch topics again. We're going to take up the last of the different units that we're going to discuss in this chapter. And we'll look at several different ways, couple different ways that you can measure angles, and again, how to switch back and forth between them.